In today's math lesson, we are going to write an equation for a parallel or perpendicular line. Now it's time for a quick review. Parallel lines. Lines that are parallel will have exactly the same slope. Perpendicular lines. Lines that are perpendicular will need you to flip the slope over and change its sign. Those are called negative reciprocals. There are 4 simple steps to writing the new equation of your line that will be parallel or perpendicular to the original. Step 1 is to determine if you are looking for the parallel or the perpendicular line. Step 2, you're going to find the slope from the original equation and then determine what slope you need to solve with based on being parallel or perpendicular. Next, you're going to plug the point that they gave you, because they are going to give you a coordinate point, and the slope that you need, that you determined in step 2, into the y equals mx plus b equation. You'll have a number in the y, the m, and the x location, and just the variable for the b, the y-intercept. Finally, either by hand or by using NSolve in a graphing calculator, you're going to solve for b, your y-intercept, so that you can write your new equation in the y equals mx plus b form due to now having found your needed slope and the corresponding y-intercept. Example 1. The equation of line U is y equals 5/4 x plus 9. Line V, which is parallel to line U, includes the point 4, 3. What is the equation of line V? Okay, well, let's walk through our steps. Our step 1 asked us to determine if we are looking for a parallel or perpendicular line. And we see here in the instruction that we are looking for a line that is parallel. Okay, good. That question is solved. In step 2, we are asked to find the slope from the original equation and then determine what slope we're going to need to solve with. So here in our original equation, we have a slope right here in front of the x. So here is our original slope m of 5/4. Now, to complete this step 2, we have to determine what we need to use. Since we are working with a line that will be parallel, we have our symbol for parallel, parallel, and we remember from the introduction that lines that are parallel have exactly the same slope. So 5/4 was our original slope, and we are going to continue to use that same slope now. Great. Now that I have the slope that I need to work with, and I was given a coordinate point. Our coordinate point, 4, 3, always written in XY order, is going to be plugged into a y equals mx plus b equation. Plugging in our numbers, we have 3 equals our slope of 5/4 times 4 plus b. And we need to solve for b. You can solve for b using a graphing calculator, or you can solve by hand, as I am here. And that either way is fine. You should be able to come up with an identical answer where in this particular problem, our y-intercept of b is equal to -2. Now it's time to write our final answer. Our equation in slope-intercept form will be y equals the slope that we needed of 5/4 times x minus 2, the y-intercept that we found as this line passes through our given coordinate point. And there you go. Example 2. Line T has an equation of y equaling 2x minus 7. Line U, which is perpendicular to line T, includes the point 10, 1. What is the equation of line U? We saw in the introduction that the first thing we need to determine is if our corresponding line, our secondary line, will be parallel or perpendicular. And we see here that it is perpendicular. The second thing we saw in the introduction was that we need to identify the slope from our original equation. And there it is. Here it is. It's 2. So with my original slope being 2, we then have to determine what is the needed slope based off of the line type that we are told to work with. Since we are finding a perpendicular line, there's our symbol for perpendicular, we know we have to find the negative reciprocal of 2. Well, we know that since 2 is positive, our perpendicular line will have a slope that is negative, and we have to find the reciprocal of 2. Since it's not a fraction, it is an integer. Remember, you can always put a 1 underneath an integer, and that won't change the value of it. Now you can easily see that the reciprocal of 2 is 1/2. So we have flipped it over. Great. Okay, the second step, we're going to find the slope. Nope, I lied. Now the third step. Now that we have found the slope, we're going to plug this coordinate point that they gave us of 10, 1. It is our x and y with the slope that we need into the equation of y equals mx plus b. Let's plug in our values. So y has a value of 1. Our slope that we're going to use is a negative 1/2. The x value that they gave us in the coordinate point is 10. And now we need to solve for our y-intercept, which of course you can do either using a graphing calculator or by hand. And we are going to do this by hand. It's not hard. You have had a lot of practice with it. I'm hoping this becomes almost an afterthought at this point in your algebra, mathematical learning and career. Yep. Okay, now that we have the y-intercept that is needed for this equation, we can write the equation. And here we go. Y equals the slope that we used of negative 1/2 x plus, since my y-intercept of 6 is positive, this will be plus 6. And there's our new equation. And there you go. Example 3. Line P has an equation of y equaling 10/9 x plus 5. Line Q is parallel to line P and passes through the point -4, -5. What is the equation of line Q? We see very quickly that this particular problem is asking us to find a parallel line. All right. And we need to determine from our original equation what the slope was. So that was easy to find. Our original slope is 10/9, as that is the coefficient in front of x. The parallel line will have the exact same slope as the original line, as that is the definition of being parallel. All right. Now that we have that, let's see what else we have to work with. We know that we have a coordinate point with x and y values, where our coordinate point is -4, -5. Let's go ahead and put that into our slope-intercept equation. Placing in for y a -5, equaling our slope of 10/9 times the x from our coordinate point of -4 plus b, our unknown at this time, y-intercept. Let's go solve for b. So this one might be a little bit more intimidating than others, and that's just fine. You know, fractions do make some people nervous, and there's nothing wrong with that. It's just how life goes sometimes. So as we go through this process of solving, we learn that working with fractions is truthfully no different than working with integers, at least operation-wise. And as a result, we end up with a y-intercept of -5/9. We would have had to have found a common denominator between our integer of 5 and our fraction of 40/9. And that common denominator would be 9. So it would have been -45/9 plus 40/9, giving you a result of -5/9. Okay. So our final equation, now that we have all of our missing pieces, is y equals the slope that we needed of 10/9 x minus, because our y-intercept is negative, 5/9. And there's our new equation. And there you go. The equation of line U is y equaling -4x plus 6. Line V, which is perpendicular to line U, includes the point 4, -5. What is the equation of line V? All right, well, we know right here that we need a perpendicular set of lines. And whenever you begin looking at parallels and perpendiculars, you know you have to start with what is the original slope from the original line. So that's a -4. And since we're looking for something that is perpendicular, we know that we have to find its negative reciprocal. Since my slope in the original equation is negative, that means the perpendicular line will have a positive slope. And due to our original slope being an integer, knowing that I have to flip it over, we can place a 1 underneath of it just as a nice visual to help us say, oh yeah, that's what's created when we flip it over. All right, good deal. So now we can say, okay, here's my original coordinate point that they gave me to use to find this corresponding line that's traveling through this coordinate plane. And we're going to plug our perpendicular line's slope and its coordinate point into the slope-intercept form of the equation. All right, n for y is a -5. N for our m, our slope, is a positive 1/4. The x is replaced with a positive 4. And we need to go solve for b, the y-intercept. Okay, so are you feeling refreshed? Are you feeling as though you have learned just gobs and gobs of algebraic equation manipulation over the course of this year? I hope so, because at this point, you have done just lots and lots. And I'm hoping it's feeling good and that you know how much you have accomplished. That's important. All right, our y-intercept is -6. This is super. Let's write our final equation of y equals 1/4, the slope from the perpendicular information, x, and this is a negative y-intercept, so it is -6. Y equals 1/4 x minus 6. And there you go. For our fifth and final example, the equation for the line R can be written as y equals -2x plus 2/5. Line S is the point 10, 1, and it is perpendicular to line R. What is the equation of line S? Here we go. Let's get started. Okay, we are asked to find a perpendicular line. So we know what type of line we're looking for. And here is the coordinate point that they gave us. And here is the slope of the original line that they gave us. Now, some of my students get nervous and they say, oh no, there's a fraction in the original equation. To which I say, so? Who cares? It's not something that we need to use. It's the old y-intercept, and keyword old, we're not using that one anymore. So don't worry about it. All right. So the new slope, our old slope, our original slope is -2. Perpendicular, one has to be positive, the other one has to be negative. Since this is -2, my new slope will be positive. And again, because this is an integer, you can put a 1 underneath of it to help you more easily visually find its reciprocal and flip it over. Now that we've got that, let's look at our given coordinate point that our new line will be traveling through using the slope of 1/2. Okay. With our slope-intercept form of the equation ready to go, let's see what the values are that we plug in for the y, for the m, and for the x as we go through the process of solving for b. Multiplying 1/2 and 10 gives us 5. Subtracting 5 so that we can get b all alone and solve for, we determine that the new and improved y-intercept is that of -4, and as a result, our final equation will be y equals 1/2 x minus 4. And there you go.